Hello everyone, my name is Diego Hernández. So today I'll present my research project, and the name of this presentation is Fair UAB Metadata for Reproducible Workflow, leveraging GeoNetwork open source. So just to start, currently I work for Gaia Resources as a spatial analyst, and Gaia is an environmental consultancy company that is highly involved in environmental studies, spatial field, and software development. They mainly, usually they support this kind of events with the OSGeo community. And on the other side, I'm finishing out my master's degree in geospatial intelligence at Curtin University. And so just to give you a little bit of myself and what I have achieved so far, what I did back at home. So mainly I have worked in photogrammetry and GIS. I'm also mentioned that this was one of the most interesting projects that I did back at home, because we aim to capture 700 coffee farms in Colombia, mainly to highlight the small coffee farmers. And so with a cartographic product, we deliver a map for coffee farmers, and in the map we highlight water bodies, the coffee farm boundary, the land area, and other features that are very important for the territory, because what is really important for them is to know what they have and how they can produce it. But unfortunately, they have only just an expectation. They don't have a real presentation, and a map, of course, will give them a reality. And on the right side of the slide, this is just like one of the first maps that I created in my past using QGIS. It's not too bad, I would say, but yes, it's just one of the first projects that I did using open source software that, of course, all of us, we support hardly. And now, when it comes about the research, firstly, the study area it is in Morisk Institute, which is around 100 kilometers away from Perth. We capture 2 barley crops using several instruments. We flew in 2023 4 times, and the main aim of the project is to develop a reproducible workflow. And in this case, as you can see on the right side, this is just an example of one of the processes that I did for producing LiDAR data. So just to give you a broad idea what this means, so we start pumping the data into DJI Terra, because we capture the LiDAR in this case with a sensor that is the XT2, and the data coming from DJI is very restricted, so you need to make sure that you process it with the DJI products, unfortunately. And then with the EXIF, or all of this information, we get the last compressed data. And finally, because the first raw data from the last product has a lot of noisy points, so I imported the information into Cloud Compare just to clean up and filter out the noisy points. And lastly, we got a nice and clean last product. And so, but now, why is it important to create reproducible workflows? Firstly, because it can be replicated by other users, like potentially one of you guys. And firstly, the workflow was addressed by following the business process model and notation BPMN language that was proposed by the object management group. This business process model and notation provides notations that are understandable by users and business, that mainly create a research or general process. And importantly, the FAIR principles that are embedded in this research in a way that is findable, because the user know how to access the data, because every single data set in this research has a unique identifier. It's accessible because the user potentially can access the data sets through the web. It's interoperable because every single data set, as I mentioned, has some metadata embedded. and reusable because it can be replicated by others. And yeah, this workflow is the same as I showed in the previous slide. Essentially, all of these notations are coming from the BPM language notation. And after that, on the right side of the slide, it is the creation of the metadata by using GeoNetwork. That is one of the things that I did by using open source softwares. And lastly, we got a digital terrain model and digital elevation model from that particular last file. So how do we construct a reproducible workflow? Well, firstly, as I mentioned, FAIR principles. They play a very important role in this research because we construct rich metadata and well-constructed metadata for datasets and workflow models. And as you can see in the slide, so for example, this dataset is a multispectral dataset captured with the MikeSend Sequoia. It's a sensor that captures the near-infrared band. And this is the workflow, how to get that particular data set. And on the right side is, well, it is expected that all of these data sets and workflows will be accessible through the web, such as repositories, could be GitHub or GitLab. We are still working on that and see how can we make these data sets accessible by a license or by request. Now, the standardization in this research is very important because GeoNetwork as a catalog application that creates metadata for spatial data resources. It works and it serves as a compliant of the ISO 19115, which is the geographic information metadata for spatial data. And we embedded this GeoNetwork because it works as a compliant. So of course we might leverage the use of GeoNetwork. And the use of the extensible markup language is embedded as well in GeoNetwork. So we might just, for example, integrate those, and we have the standardization embedded in the research. And one of the biggest challenges in this research was to basically to ensure the reproducibility and reusability of the datasets. We have to review several standards and the elements for capturing the geographic information, in this case drones. And this is one of the, I'll say, the significant part of using GeoNetwork, because essentially the ISO 19115, just to represent, they call it resource because essentially a dataset is a resource. You only need to display the title, the abstract, and the point of content and date of publication. But to actually proper document and to have a rich metadata, you need to do filter of that. So in this case, all of these elements and classes of the ISO 19115 was successfully captured by using GeoNetwork. So information such as spatial representation, reference system, the acquisition information, lineage, platform, instrument, all of those groups of elements were used in the research. And on the right side of the slide, it is one of the examples how we capture this information, and this is an example of the multispectral raw data displaying the Sequoia instrument, and we should describe it in GeoNetwork. It's pretty powerful for creating metadata. And then lastly, this is one of, I'll say, the results that I have achieved so far using GeoNetwork. So the raw data set is basically displayed on the GeoNetwork, and including all of the ISO 19115 elements, and it can be read by humans and machines. And then on the right side is the workflow metadata that is basically pulling this information to process the raw data set. And yeah, lastly, we have the well-processed data set with rich metadata. Yep.
You said that early on that you had to clean up your data.
Yep.
Are you able to capture that process in the metadata?
Yeah, so well, it's a bit hard to see in this one. Oh, yeah. So what is important in this is the BPM language is very friendly for humans. So you might just see the notation and say, well, this is the process. But, well, for machines, it doesn't work like that easily. So, this case here is the lineage model that what it does, the extensible markup language XML is capturing every single process step. And we ensure that everything that is in the BPM language, it is placed into this metadata. So of course, we create metadata for datasets and the workflows. But on a point that I forgot to mention is, so we won't test the production of every single dataset. That is, I would say, out of the scope. Maybe that it will be a future research if I decide to do PhD, not sure yet. But yeah, it is still something that I need to decide with my supervisor.
Your data, I'm just curious about what does the data look like for the spectral image? Are they just numbers? And the data collected from the drone with the spectral imagery machine, whatever you have it, is that, do they have the GPS coordinates and then you've got your spectral image data, and that's recorded on what, SD card or?
All right.
Whilst you're, yeah, the
So,
data collection I'm interested in.
So it depends about what you are capturing, firstly. So just give you an example. So in terms of multispectral data, so what it does, the camera, you have your sensor you attach on the drone, and when you are flying, you have, depends if the sensor has, say, 4 bands. So the raw data that you will have 5 images, 4 bands that will be green, red edge, near infrared, and the RGB bands. So in your SD card, in this case, you will have, like, I don't know, if you yeah, in the SD card, if you capture, I don't know, 100 images times 5, it will be, yeah, what's that? 500.
512 gig.
Yeah, well, 500 images you will have.
Oh, fine.
Yeah.
So what's the size of SD card you need to use on your drone?
Well,
You have to actually fly a few times.
no,
you have to
but
fly a few times over or what?
yeah, well, for example, for this one, that was one of the specifications that we did. We flew at 3 different heights to ensure that we were capturing the right data, because usually you need to have side lab and front lab for drones. So if you don't, suppose you are flying, we flew very close, 100 kilometers away is not too far. But if you are, suppose you are flying 1,000 kilometers from home, and then you go there and you lost your day, you go home and say, this part is missing, you need to come back again. So with that, to ensure that you are capturing well, you need to have at different heights, but importantly, you need to respect the CASA rules. So the maximum altitude that you need to do is 120 meters. So that is something that you need to be aware as well.
Is that drone over 2 kilograms? No, 250 grams, it's over 250 grams.
Exactly. There are many rules involved.
So one needs a license.
Yeah, you need a license. Correct. But it depends about the drone that you are using. If you ask me about the raw data, how it looks like, yeah.
Yeah, that's interesting. Interesting.
Yeah.
Are you able to keep a track of uncertainty related to
You mean maybe like data quality?
Yeah, it could be data quality or precision or.
So, for example, when it comes to this, one of the best one to measure is the absolute accuracy. So using ground control points. So we place into the field 12 ground control points with RTK. So we placed with the RTK and we went and I spread out all of the eggs around the crop. And then using, unfortunately, one of the constraints that I'll say of the research, I started using OpenDrawMap because I like open source products. But due to my machine constraints and, well, maybe financial situation, because you can run this in a virtual machine, but this is out of the scope of the research. So I asked my supervisor, do we have another option? Yeah, we'll just use InfoScan, Agisoft. And then you just place your ground control points into the software, and then it will give you the R-square error. And the one that we got, it was pretty accurate, I will say. I can't remember, but it was like 0.2 centimeters. Yeah, it was pretty good. Well, drones, as long as you have a good overlapping and ground control points, it will be fine.
All right. Thanks, Diego.
Thank you.
Let's give you this back. There you go. All right. Excellent.